Hi, so welcome back to part 2 of the mock exam for the AS level paper of June 2022. So question 6 says the sum of the first 20 terms of an arithmetic progression, it's very important that you understand it's an AP, is 405, and the sum of the first 40 terms is 1410. Find the 60th term of the progression. So we are asked to find what is the 60th term. So what do we know? We know that the sum of the first 20 terms, that will be given by the formula 20 over 2 in bracket 2a plus, now it's 20 minus 1. So I'm going to have 20 minus 1 times d. That should equal to 405. So you can clean this up. So that's 10. Then you have 2a plus 19d equals to 405. Well, that would be my first equation, okay? Or I have 2a plus 19d equals to 40.5. So what I did there is I just divided by 10, okay? Both sides. So this is my first equation. So I'll use similar concept to do the second equation. So the second equation would be the sum of the first 40 terms, so that is half of 40, that's 2a, plus 40 minus 1 times d, that's 1410. So we can clean this up. So this gives me 20, then you have 2a plus 39d equals to 1410. Again, I can also clean this up by dividing by 20, so it's 2a plus 39d. If you divide that by 20, you get 70.5, I believe. 70.5. Okay, that is 1410 divided by 2. Okay, by 20, sorry, by 20. So it's 70.5. Good. So this one here, I just divide it by 20, and that is my second equation. So you get independent marks. That's a B1, that's a B1. Call them independent marks for those two equations. Now, the only thing that you need to do for this point onward, because you need to find your value of A and D. Why is that important? Because in order for you to find the 60th term, you need to know that this formula here, so that is n minus 1. So you'll have to say, okay, so the 60th term will be whatever A is plus whatever D is, and then 60 minus 1. You see that? In order for us to find the 60th term, we need to know the values of A and we need to know the values of D. Hence, we are creating those two equations, solve them simultaneously, and then we substitute in that correct formula. Okay, so however much you go about it, I can say this is equation B and this is equation A. So what I'll do is I'll say equation B, take away equation A. So that is bring, let me just take my two equations and rewrite them again. So, or I can simply look a bit smart. So my equation A happened to be 2a plus 19d equals to 40.5. So we're going to subtract, right? The whole thing. So when you subtract here, well, I believe that you know how to do, how to solve simultaneous equations, okay? That is 20 here, so that's 20d, and then the next one is 70.5 minus, so it's 30. So this answer here is 30, I believe, and d would be 30 divided by 20, which is 1.5. Now you can actually solve to find the value of A. So you can substitute D equals 1.5 into A or B. Doesn't matter in which equation you are substituting it into now, right? So I'm just going to substitute into A. Doesn't matter. So what was our A? It is 2A plus 39 equals 70.5. And we said that D is nothing but 1.5. All right, so 39 times 1.5 gives you 58.5. So that's 2A plus 58.5. Well, you're going to move that 58.5 over. You're going to have 2A equals to 70.5 minus 58.5. So 2A will equal to, let's have, so 70.5 minus answer is 12. Therefore, A equals to 6. Right, so we now know what our A value is. So what is the 60th term? Is A, which is 6, plus the value of D, which is 1.5, and then 60 minus 1. Okay, some people they write the 1.5 on this side, doesn't matter. And from here onwards, you just hit the calculator, or you enter the stuff in the calculator. So it's 6 plus 1.5 times 59. Okay, 94.5. So the answer is 94.5. Therefore, the 60th term is 94.5. There we go. We took care of that question. All right. So you get a mark for substituting the correct formula. Obviously, a method mark for solving the simultaneous equations, and then 2 independent marks for creating the equations in the first place. Right. Question 7. A little bit tricky, but not so much tricky. So this one says the 5th and the 6th term and the 7th term of a GP. Very important that I know I'm dealing with a GP. So what is the formula? The T sub n of a GP is ARN minus 1. The other formulas also for sum to infinity. Sum to infinity is A over 1 minus R. Okay. That I will have to know. Okay. For this question. So what do we know? We know that the 5th term and and then the 6th term and then the 7th term. So let me just choose a nice color. So the 5th term is 8k, the 6th term is negative 12, and the 7th term is 2k. Okay, good. Right, so we need to create form an equation in k and solve that. So that would be my first method. So that would be like saying term 6 divided by term 5 should be exactly the same as term 7 divided by term 6. Hopefully you are aware when we are dealing with geometric progressions, you divide the terms too. So term 6 is negative 12. Term 5 is 8k. It should equal to term 7 is 2k and term 6 is negative 12. All right, so you can just go ahead and say cross multiplication if you want to solve that. So that's going to give me, and I'm going to write it here, that's going to give me negative 12 squared equals 8k times 2k. That's 144 equals 16k squared. At the end of the day, you will see that this is the same as saying k squared equals 144 divided by 16 then k squared equals to 9. And if you were to solve this, you will say k equals to positive or negative root 9, which is k equals to positive or negative 3. But we are told right here that k is negative. Okay? So our only acceptable answer at k is negative. Therefore, k equals to negative 3. Okay, so we have our k. So we can actually form our sequence. So let's bring in a different color. So it's 8 times negative 3, negative 12, and 2 times negative 3. So our sequence would be term 5 is minus 24. Okay. Term 6 is minus 12. Term 7 is minus 6. Okay, from that. Why is this important? I can find my R. R is either to take term 6 divided by term 5 or term 7 by term 6. So term 6 is negative 12 and negative 24. Okay, and this gives you a half. So R is our common ratio is a half. Why is this important? Because we need to find a sum to infinity, so we need to know what is R. So now I know what R is, and I need to find my first term, A. So our A, when you are using the formula T sub n equals to A R n minus 1, okay? So our value of A, I'll say A equals to, I'll take a half, which is my, no, let me not write it like that. Let me say A, and then here I'm going to use, I can use the fifth term. 5 minus 1, I can use the fifth term, which I know is minus 24. I could also use the sixth term, doesn't matter. Okay, or the seventh term, doesn't matter. This is all going to give me the value for A anyway. So that is going to be 4, and a half raised to the power of 4 is going to be the same as 1 over 16. So this is A times 1 over 16 equals negative 24. And therefore A will be negative 24. Now you're going to multiply that by the inverse. So the value of A is negative 384. Okay, use a calculator. Make sure you get that. So now we know what is A, we know what is R. So A equals minus 384. R equals a half. So therefore, the sum to infinity, which is A minus 384 over 1 minus a half. Okay, so let's just punch it in. Oops. Grab my calculator. So it is negative 384 over 1 minus a half is just a half. You agree? That gives you minus 768. Alright, so there are quite a number of steps to that question. Alright, my sum to infinity, my infinity symbol looks kind of, yeah, it should be like an 8 upside down. So that is the solution to this question. So there are quite a number of steps that you had to take. And also, it's important, that's why I typed this in red, because I wanted to bring your attention to it, that k is negative. You had to form an equation. That was your method mark that is there. Okay. Deducing k is equal to negative 3. That's another A mark. That's an accurate mark that we are looking for. And then the method mark for you to substitute in the correct formula, which means, you know, the formula here and then obviously the correct answer minus 768. Okay. Step by step, you can always go back and you can always pause the video and check how we solve those questions. Okay, they're always going to be in your examinations questions on APs and GPs and word problems, like last year's paper. The volume of a spherical balloon is increasing at a constant rate of 50 cubic centimeters per second. What does that mean? It means that the volume, which we know is 50 cubic centimeters per second, that's the volume with respect to time. That's what this is, dv dt. Okay? And we also know the thing is a sphere, right? So you need to know the following. The volume of a sphere. Right, so what is the volume of a sphere? Well, if you don't know, it's 4 over 3 times pi r cubed. Then you go to the list of formula and notations, and you will definitely see, I think, on page 28 or something like that. On page 28, right at the bottom, this formula are provided to you, so you must use it. Here you go, volume of a sphere, 4 over 3 pi r cubed. All right, so we're going to use that. Volume of a sphere, it's 4 over 3 pi r cubed. Okay. What else do I know? I am also given that the radius is 10. Find the rate of increase when the radius is 10. So in a nutshell, what is it that I'm supposed to find? I'm supposed to find dr dt. That's what I need to find. Find the rate of increase when the radius of the radius, the r, when we have the radius when the radius is 10 centimeter. Okay, so we need to find the r dt. But what we have, so here's the thing about when you write this like that. Remember from your chain rule, and this is something I always say, think of that dr over there times and then the dt over here. So what we need to have here should be exactly, the same thing, because that dr dt is like the r on top, like, like you're cross multiplying like that. Can you see that? So what is it that we need to know? Of course, we need to know dv dt. All right, we know dv dt, sorry, but what do we have here is we need to know the volume. So I'm just going to choose dv here and dv here. Now let's look at what we have so far. Do we have dv dt? Yes, we have dv dt. dv dt is 50 cubic centimeters per second. I'm just going to write the units now, like that. So what do I need? I need dr dv. But here I have a problem. If I work this out, in order for me to find dr dv, I must make r the subject of the formula, and that will be a horrible and a very long way of looking at it. So let us find dv dr. Okay, we're going to differentiate with respect to that. So you know how to differentiate that 3 multiplied with that. That's going to give you 4, excuse me. Or let me just write it down so that people can follow. 3 times 4 over 3 pi r. Now you subtract 1 there. So this answer is 4 pi r squared. So this is dv dr. Are we following so far? But I have here dr dv. So in order for me to have this as dr dv, so I'll just swap this around. So I'll say, wait a minute, dr dv is going to be 1 over 4 pi r squared. So I'm going to bring that 1 over 4 pi r square here. So now I have dr dt as 50 over 4 pi r square. So that's my derivative formula. But I'm looking for when the radius, right, find the rate of increase, when the radius is 10. So when r equals to 10, that means I'm going to have dr dt as 50 upon 4 pi, and in here I'm going to put 10. Okay, once you clean it up, you get 1 over 8 pi. That is going to be centimeters per second, because you have got your radius with respect to time. At the end of the day, you can also accept things like 0.03978 blah 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 centimeters per second. To three significant figures, it becomes, which is 0.0123398 centimeters per second. That would be correct to three significant figures. But this question here, or this answer here, in terms of pi, 100% correct. All right, so you need to read these type of questions very careful. This is also a question you can find in your textbook. For those of you who have the y equals mx plus c textbook, I think it is on page 282. Okay, I think it's question 2. So check it out. I did this and brought it in. I have a different way of doing it. Maybe you look at those examples. What you need to identify is your units. They play a role. The volume here per time. So that is dV dt, which is equal to 50 cubic centimeters per second. And then they're asking you find the rate of increase of the radius. You have to find the radius, and that always with respect to time. Okay, so dr dt. Once you have this, you write it in as you do chain rule. The dr on top, dt under. What you need to have here is dv dv. Okay. Now we know what this one dv dt is. We just wrote it from the information on top. But this one is dr dv. But when you differentiate the volume with respect to radius, you get dv dr. Since you're not looking dv dr, we're looking for dr dv. You calculate dv dr. Now you swap it around. Now you can substitute in there, and then you have your derivative formula with the radius with respect to time. But we are looking for the rate of increase of that radius when the radius is 10 centimeter. As you are increasing the volume of this, so does the radius also increase. What is going to be that radius? The rate of increase, centimeters per second. Radius is distance. Time, dr dt, time is the seconds. So make sure your units are also okay. Okay, all right. So it's a very interesting question. It's actually a very favorite question of mine. So please know how to solve these questions when we are dealing with volumes and this type of questions. Question 9, we can squeeze in question 9. A farmer keeps cattle in a rectangular enclosure. He uses fencing of 3 sides and a wall. So the wall is this darker part here. So this is the wall. Okay, so that's the wall, please. So the fencing starts from here all the way up. Y, X, Y. Okay. The fencing he's using is 200 meters in total length. So we need to find the greatest area you can enclose. The moment you get these type of things, the greatest area, we're going to deal with differentiation questions here. But let's see what we have so far. We know that the area of this rectangular enclosure, the area is calculated by saying x times y. That basically is going to be my first equation. The second thing that I know, the perimeter, so I have 2y's plus an x should give me 200. That could be my second equation. Remember, the wall is on the other side, so that's only why I have an x, only one x there. Okay. Now, if I make x the subject of the formula here, x will equal to 200 minus 2y. So in a nutshell, I have this equation here, and I have that equation over there. So you are going to substitute, okay, equation 2 into equation 1, because we are looking for the greatest area that it can enclose. So what we're looking for is dA dy. So basically we're going to look for that, the greatest area. So greatest area, we need to find the derivative of that. So anyway, so we're going to substitute equation 2 into equation 1. So that gives me a equals to 200 minus 2y times y. So I can clean this up a little bit. So I'm going to have 2y squared. Okay, that 2y squared is sort of minus. So I'm going to just rewrite it nicely. So that times that and times that. So that's going to be 200y minus 2y squared is equal to the area. So why is this important? The maximum or greatest area is the same as saying what is the turning point. The turning point now of the function. So this function is a quadratic function. So the turning point of that function, at the turning point of that function, the gradient is equal to 0. That's one of the things you must remember. Because if you were to sketch that graph, it's going to be something like this, obviously. And at the turning point there, the gradient is equal to 0. Okay? So degree dy is equal to 0. So we need to find the derivative of that, let it equal to 0, and then we solve for y. Okay, that will give us one measurement. So that means dA dy, okay, if you differentiate, that's going to be minus 4y. Okay, it's minus 4y plus 200. Okay, hope you still remember how to differentiate. Okay, that's going to be 200 minus 4y. Right, so what did I say? At the turning point, we know that dA dy equals to 0. At the turning point, like I said before, so that's minus 4y plus 200 equals to 0. Now, you simply solve for y. So minus 4y equals to negative 200. That is y will be negative 200 divided by negative 4. Therefore, y is 50. So if you have y equals to 50, now we are going to substitute. Remember this one here, I'm going to highlight it because I want to find the value of x, okay? Because the question says find the greatest area. In order for us to find the greatest area, we need to multiply our y with the value of x in order for us to find the greatest area. And when to find x, so the equation there is x equals to 200 minus 2y. So I'm just going to bring in a different color. So x equals to 200 minus, let's go back, 2 times y. 2 times y. And what is the value of y? Well, y is 50. So that is 100. So x is 100 and y is 50. So the greatest area would be 50 meters times 100 meters, which is 5,000 square meters. And this is the solution to that question. All right. So there's a bunch of steps that you need to follow. Creation of this equation, looking at the information, will give you a guide as to how to solve and go about with this problem. All right. Let's see if we can squeeze question 10. Now, question 10, which is where I'll end this one, and then I'll do the second part. I'll do from question 11. Question 10, you have two fractions, okay? Something on the right-hand side and something on the left-hand side. So what you need to do is two fractions on the right-hand side now. So I'm just going to write here, add the two fractions, these two, okay, on the right hand side by finding the LCM, lowest common multiple or lowest common denominator, and the equivalent fractions. So what does that mean? So I'm going to say that the one on the right hand side, I'm going to say, okay, right hand side, I'm going to say x minus 2, x plus 3, and this d is going to get x plus 3, okay. Now to add and subtract fractions, plus e, and then e is going to get x minus 2. Okay, right. So let me just multiply out. So I'm going to have dx plus 3d plus ex minus 2e all over x minus 2, x plus 3. Now, if I'm there, I can look at the coefficients now. I can say, look here. So you have, that is the coefficient of x. So I can write it as d plus e with x. And the other ones, they're just going to be, you know, constants. 3d minus 2e is just a constant. Okay. All over x minus 2, x plus 3. Okay. Right, so now I've done that. So now I'm going to take those two and I'm going to equate them with the coefficients, okay? So if you look at the coefficient of x here, the coefficient of x is simply 1. Therefore, I'm going to take this d plus e and I'm going to let it equal to 1. So I say d plus e is equal to 1. Okay, that plus looks a little bit lonely. So let us just have nice. So this can be my first equation, if you want to say it or do it like that. Okay. I can actually clean this equation up a little bit more. But I'll come back to it. So let me just then take the other ones. So these 8, which represent the constant, this one here, I'm going to let it equal to this whole stuff here. Are you with me? So that means I'm going to say 3D minus 2E will equal to 8. So the objective now is to solve these two equations simultaneously, and you find the value of D and the value of E. Okay, so how do I go about doing that? Well, you can say I'm going to multiply this whole equation here by 3 so that I can make the D's, no? The coefficient of D is the same. That is called the method of equal coefficients. And if I do that, I can then eliminate. So when I multiply, I'm going to have 3D. That means each term must multiply by 3 plus 3E equals to 3, not 1, equals to 3. Okay, good. Well, this one here I just multiply by 1, so it's going to be 3D. Now, it doesn't matter. I'm just going to write it on top, okay? So it's 3D minus 2E equals to 8. It doesn't matter which one you put where, okay, as long as you eliminate. So I eliminate by subtracting, because the 3D and 3D, they eliminate by subtracting. Now you must be very careful. Minus 2 minus 3 will give me negative 5E here, if you do that. And 8 minus 3, well, that gives you 5. Okay, so I am getting the value of E as negative 1. So far, so good. So I'm going to go back all the way to my original equations. Doesn't matter which one you choose. I'm obviously going to choose this one in order for me to find the value of D. So that is D plus E, which is negative 1, equals to 1. Okay, right, so I think from there you see that D is equal to 2. So that's D minus 1 equals to 1, and D equals to 2. Therefore, E equals to negative 1, and D equals to 2. Quite straightforward. Now, you can also find a similar question if you are using your y equals mx plus c textbook. Yeah, y equals mx plus c. You find a similar or exactly the same question, just different letters there. Look on page 37, okay, and look at question 18. Right, so what I did is when I set up this paper, I took some of the questions from your textbook so that you can also see the work that you have done and if you can still remember them and things like that. Okay. This question here, question 11, as I said, I can do it together with this particular video, and then we then look at the third installment, so to speak, will be from question 12, and then there's some methods there that I've introduced that I want to introduce, and then question 13, graphs, and then question 14, and then there's the last question also on sketching of a graph. So we can actually do question 11 also in this video here. Prove the identity. Well, this is 2 marks, so here you can decide where you want to start. So I'm just going to be a little bit maybe I'll take the long side for obvious reasons. Okay, so what I will say is, remember, this is the left hand side and that is identical to the right hand side. So I'm going to look at the left hand side. Well, we may start with the right hand side, but I'll start with this one and I'll also do the right hand side, and you'll see that exactly the same thing. There's nothing to be afraid of when you are dealing with this identity. Now, I hope you're familiar with the Pythagorean square identity that says sin square theta plus cos square theta is equal to 1. And if you were to make cos square theta the subject, you get 1 minus sin square theta. If you were to make sin square theta the subject, then it's 1 minus cos square theta. Okay, so I've just built like extra ones from the general one. So what does that mean? So when you look here, I have 1 minus 2, but that's sin square theta there, right? That's sin square theta. I'm going to replace it with 1 minus cos square theta. 1 minus cos square theta. Okay, totally up to you which way you want to go. And then I have under 1 minus sin square theta. And 1 minus sin square theta, from what I have written here, is nothing but cos square theta. Are you so far with me? Okay, right. So the numerator there can definitely sort of, I can multiply out. So that's going to give me, that's the left hand side. So that's going to give me 1. Then I have minus 2 cos square theta over cos square theta. Okay, not totally done yet. The numerators there, they becomes minus 1. It's minus 1 minus 2 cos square theta over cos square theta. So I'm just going to separate the two because over a common denominator. So it's the same as minus 1 over cos square theta minus 2 cos square theta over cos square theta. I hope you follow. I just want to make sure a little bit of my multiplication here. That's supposed to be a positive. Negative 2 times a negative is a positive. Goodness gracious, that would have been something else. Okay, so this makes this a positive. Right, so what else do I know? This is just going to be 2 because the cos square theta, they cancel. And what is this? Remember that if you have 1 over cos theta, that is nothing but sec theta. Yes? Again, if you don't know this, if you don't know this concept, then you go check in this particular paper, look at page 28. So I'll list a formula. You must use that so that you do not go wrong. So let's quickly go see, because you must make sure you use the correct identity. Page 28, list of formula. Here I go. Oops. So where do I go? All right, so here we are. I said 1 over cos. Just want to make sure. Okay, let's go back to the identities. So this one is the one that I also used. Cos square theta plus sin square theta is equal to 1 or identical to 1. Then, okay. Yeah, this is the one that I'm looking for. Sec square theta is 1 plus tan square theta. I'll come back to that. Why is that so important? Okay, because remember, I had something like a negative 1 over cos square theta, which is the same as negative 1 times, now cos square theta, that is sec square theta. Can you see that? Because 1 over cos is sec theta, right? If that is the case, then I will take this whole thing here and I'll replace it in sec square theta. Okay, I know it's a long way, but ultimately that is what I'm going to do. Okay, because I decided to go that route, I'm going to stick with that route. But I'll show you the other way where it's actually much easier, but you should also know how to go both ways. Okay, so again, as I was saying, I know that from my list of formula, I know that sec square theta is identical to or equal to 1 plus 10 square theta. So this is actually minus sec square theta. So I'm going to have minus plus 2, and then in the place of that I will have 1 plus 10 square theta. Now I can go ahead and sort of multiply out. I get minus 1 minus 10 square theta plus 2. And 2 minus 1 is going to be nothing but 1. Okay, so the answer would therefore be 1 minus 10 square theta. And this left-hand side is very much equal to the right-hand side. Check the right-hand side, 1 minus 10 square theta. Okay, so that was one way of going about it. I know it's a little bit longer, right? But it still pays the bills. Well, what if someone else says, but sir, that is a bit too long, and I didn't go that route. Well, you're still within your rights to go the other way around, okay? I just want to see something about my question. All right. So, I hope that you have recorded it. I just want to create space so that I can see what if I then decided to take the right-hand side. I'm just going to do it next to the other work that I have done. Okay? But it's 2 marks, so I believe that this way, the one that I'm going for now, was preferably going to be the best option. Anyway. Okay. All right, so let's just separate that like so. So let's say we are going the other way around. Okay. And there's nothing to be afraid of then if you go the other way around. You simply will say, okay, the right hand side, maybe I can use, I would say right hand side would be 1 minus, now 10 square theta, here's the thing, tan theta is nothing but sin theta over cos theta. Okay, so I can say sin square theta over cos square theta, and then I separate them. Okay, common denominator, so that's going to be 1 over, okay, remember if I now, because it's 1 over 1, so it's going to be cos square theta over cos square theta minus sin square theta over cos square theta. You can also do that if you want to. Okay, and then what you have on top there, you have cos square theta minus sin square theta all over the same denominator, and denominator is cos square theta. Now let's focus on that numerator for a minute, because you see on the left hand side you've got things in terms of sign. So I know that cos square theta can be written as 1 minus sin square theta. So this cos square theta on top, I'll write it as 1 minus sin square theta minus sin square theta all over, again, this cos square theta under can be written as 1 minus sin square theta. That will take care of my denominator. So that's 1 minus sine square theta. So I'm nearly done, but I've got some like terms there on top. I've got 2 sine square thetas there. So the answer will be 1 minus 2 sine square theta over, okay, over 1 minus sine square theta. And this right hand side, okay, would equal this right hand side would equal the left hand side. Okay, 1 minus 2 sine square theta. Can you see that? Over 1 minus sine square theta. So that is also one way. I believe that this is going to be much easier, but of course, you always have to also know the other approach to this. So this is the end of part 2 of this mock exam. I'll be doing part 3 in a bit.